Hi friends, now let's get into the second type of page structuring, which we call hash table paging. Before getting into, let's just look what the hash function is all about. So hash function is the one which maps the virtual page numbers to an index in the hash table. So we have a small hash table, and this hash table is a small one of a limited size, and the virtual page numbers are directly mapped to the index of hash table. And the advantage of working with the hash table is it's efficient lookup of physical frame numbers. And the commonly used hash function is finding the modulo operation with the virtual page number mod n, where n is the size of the hash table. So VPN is the virtual page number, and n is the number of slots or buckets in the hash table we have. That's usually the power of 2's or a prime number. How does it work? So first thing is the VPN extraction, where operating system extracts the virtual page number from the virtual address and then applies the hashing function to compute the index using the VPN. So VPN mod n will be the hashing function, and through that index is calculated, and at this computed index, a bucket or a linked list stores the mappings. And this is how the mapping is done, and this is how it is searched. So it becomes quite easy to locate any virtual page on the hash. So there is a possibility that there will be more than one VPN can get the same hash index, because we are doing a modulo operation. Then that means after every n the cycle, the remainder keeps repeating from 0 to n minus 1. So the first for 0 it will be 0, then 1, 2, 3, 4, it goes up to n minus 1, and when the value is n, then the modulo value again gets down to 0. So 0 to n minus 1, 0 to n minus 1, it's keep repeating round and round and round. So when we are talking about a very big number, then there is possibility that more than one VPN can get the same index. That's what we call collision. And when such collision happens, then instead of using one bucket, we can use a linked list that stores all these multiple VPNs into the same bucket. So as an example, we'll only explain what we were trying to say. So if we assume that we have a hash table of 7 buckets, 0 to 6, then any given number you just divide by 7, and whatever is the remainder will be the index in the hash table. So if the value is 0, it occupies this bucket. If the value is 1, it occupies this bucket. For value 2, it occupies this bucket, and 3, 4, 5 and 6. So when the value is 7, so 7 divided by 7 is 1, and remainder is 0. So therefore it comes back to the bucket 0. For 8, it comes to index 1. For 9, 10, 11, 12, 13, 14, 15 and so on. So after every 7, this whole thing gets repeated. So we have a hash table with buckets 0 to 6, totally 7 buckets. And if you assume that we are storing our values in this order, 15, 11, 27 and 8. So 15, if we look at it, so 15 if you divide by 7, then we get a 1, because the remainder is 14 plus 1. 14 is multiple of 7, so 14 plus 1, therefore the index in the hash is 1. So under 1 we added 15. Then we got 11. 11 means when you divide 11 by 7, remainder will be 4, so add 4, we get 11. Then we had a 27, so 27 by 7, that makes 6 remainder, because so when you divide 27 by 7, it is 21 plus 6, that is 27. So the remainder is 6, and the next number is 8. 8 means 8 by 7, that means 1 times, and then we have a remainder 1, therefore bucket 1 it takes. Bucket 1 is already occupied, therefore we create a linked list and continue doing this. So this is how we add our numbers into this hash function, hash table. And when we are looking for whether such number exists or not, when we are searching for it, the easiest thing is just what you want to search. Say I want to search say 9. 9 means what should be the remainder? 9 by 7 is 1, remainder is 2, so look at 2. Do you find a 9 in this? Nothing. Therefore in our list 9 does not exist. So that is as simple as that. So that way hash function can be used for creating a page table. Now gets into hashed page table. So this is a common approach for handling addresses whose spaces is which are larger than 32 bits. So hash value being the virtual number contains a linked list of elements that hash to the same location, that is to handle the collisions. So the main logic is shown here. So we have a logical address which is made up of page number and the displacement, and the page number goes to the hash function, and the hash function says which is the index. So that hash function is one function, maybe a modulo function or something else. So it takes a big number and gives one particular number, and that number serves as an index to the hash table, and that index will be having a linked list, and there we are looking for. So what are we looking for? We are looking for P, and when we are looking for P, we get this particular index in the hash table, and after that index, if you look at it, we are getting a linked list. So the first one talks about Q, then we have yes, and then so on. Then we have P here. Yes, we got a P. P, where is that P is? P is located in the frame number R. So Q is located in frame S, P is located in frame R. So R comes out as a frame number, and D we get as this from the displacement, and together it finally creates the physical address.